Welcome back, Union High School Pre-Calc. We hope you are doing well, that limits graphically is going well so far. Today we're going to be looking at another way of finding limits, and that's numerically, also known as with a table. Just as a reminder, there are three ways to find limits, and you don't need to write any of this down yet, but the first one is graphically, which is what we did last time. And then we've got numerically, which is what we're going to do today, and that's when you are analyzing your function with a table. And then the third way, which is what we're going to do next week, is algebraically or analytically. And that's when we're going to give you your function as an equation, like f of x equals sine of x. Alrighty? Okay, so as a review, actually first, you are going to want a graphing calculator for this section. So a TI-84, sort of like an app, should have been pushed out to your school laptops. Now, the first time you use it, you're going to need this code. So you can either pause the screen or you can check the notes on Canvas, because it will be, these exact notes will be on there. So you'll need this code the first time you use the 84 on your computer. You can also use your own calculators at home if you have them, or of course always Desmos, and I will show you both the 84 and Desmos for this today. Alrighty, now as a review, we talked about limits last time, and what I want to really go over again is the difference between a limit and a function value. So hopefully you see both notations here, okay? So this first one is the limit as x approaches 3 of g of x versus g of 3, okay? So do we remember what's the difference? So the limit is what is happening around x equals 3. Okay, the function value is what is y when x is equal to 3. Okay, so limit what is going on around. In other words, what are we, remember what word we want to link this to. So what are we approaching versus where are we at exactly? Okay. And they may be the same or may not, right? So let's take a look at an example here. Try this again. All right, so take a look at this graph. Can you decide what the limit and the function value is? So let's draw our guide here. So if I approach x equals 3 from the left, it looks like I'm approaching y equals 4. And again, if I approach from the right, I'm getting that same y value. So the limit in this case, as x approaches 3, this was g of x, is 4. However, the function value is what is y when x is 4. Well, here I can see that when x is 4, y is 2. Okay, so again, the limit is what's happening around x equals 3, and the function value is what is y when x is 3. Okay, so we're going to kind of extend this idea and look at same concept, still limits, but this time your function will be given as a table instead. Okay, so let's take a look at this. So both the table and the graph are shown for f of x. Can you find the limit as x approaches 0 of f of x? Alrighty, so let's look at the graph first. Let's draw our guide at x equals 0. And it looks like as we approach that guide from the left, looks like my y values, I don't know if you can tell there, are approaching 0.5. And if I approach from the right, looks like still 0.5, correct? So from the last lesson, I'm going to say that the limit as x approaches 0 of f of x is 0.5. Okay, that's what it looks like graphically. Now let's try this numerically. So I've got a table that represents that same function with a few selected x values shown. Okay, so take a look. We've got some x values that are less than 0, right? So think about that. That would be coming from the left, correct? And we've got some x values greater than 0, so that would be coming from the right. And then we've also got what is y when x is 0, but if I'm considering the limit, I don't care about the function value, right? Because the limit's just what's happening around. So I'm actually going to totally ignore that line if I'm finding the limit, okay? All right, so here's what I'm going to do. Let's focus on the left and the right-hand limits separately, just like we did for graphical limits. So what I'm going to do is actually block out the x values that are greater than 0. So let's focus on this part here. This would represent the limit as x approaches 0 from the left of f of x. All right, so now let's follow those y values in the same way. Does it look like your y values are approaching any certain number? It sure looks like they're approaching 0.5, right? Okay, let's do the same thing coming from the right-hand side. So this time I'm going to ignore the x values less than 0 and focus on the x values greater than 0. In other words, see how these are all greater than 0, but still very close to 0 and approaching x equals 0? So this side would represent the limit as x approaches 0 from the right of f of x. So let's follow that same arrow, but looking at the y values, does it look like the y values are approaching any certain number? Sure looks like they're approaching 0.5 as well, right? So yes, indeed, which is what we saw graphically as well, that the limit is indeed 0.5, okay? So that's kind of what we're going to be doing, except you will not typically be given both the graph and the table. I just wanted for you to see sort of the comparison there. All right? All right, let's try one like this. Okay, so we would like to find the limit as x approaches 5 of f of x. So remember that what happens right at 5, I don't care about that, right? I just care about what's happening around 5. So I'm going to totally block that value out if it's even given at all. So once again, let's go left and then right separately. So I'm going to hide all the values greater than 5 first. So let's look at these. These are all values less than 5, so this would give me the limit as x approaches 5 from the left of f of x. So if I follow the y values in that same order, what does it look like the y values are approaching? It looks like they're approaching 75, right? Okay, let's try, woohoo. Let's try that going this way as well. So I'm going to block out those. Now let's approach 5 from the right-hand side. So see how I'm approaching x equals 5 here? So this would give me the limit as x approaches 5 from the right-hand side of f of x. So if I follow the y's in that same order, what does it look like the y values are approaching? They're also approaching 75, okay? So since the left and the right-hand limits are the same, the full limit exists and it is equal to 75. All right. All right, can you pause the screen, and you don't need to necessarily write this down, but can you decide what the limits are as x approaches 0 of each of these 3 functions? So you've got f, g, and h here. Can you decide what each limit is for me? So pause the video and then we'll come back. All right, so let's see how you did. Let's take a look at f of x first. So notice that this would give me the left-hand limit as x approaches 0, and this way would give me the right-hand limit, okay? All right, so let's take a look at f of x. So going for the left-hand limit, and let's do this also. Let's go ahead and ignore the function values, right? Because I just care about what's happening around around x equals 0. So as I go this way, what does it look like the y values are approaching, or the f of x values? Looks like they're approaching 2. What about coming this way? So this would represent the right-hand limit. Is that also 2? Yes, it is. So I can say that the limit as x approaches 2 of f of x, the limit as x approaches 0 of f of x is 2. Okay? All right, let's try g of x. So again, this would be the left-hand limit. So it looks like the left-hand limit is 1. This would be the right-hand limit. What does it look like the right-hand limit is? Looks like the right-hand limit is 2, right? And I don't care about the function value. Since the left and the right-hand limits are different, what can you tell me about the full limit? No, does not exist. Okay? All right, let's try g of x. This would represent the left-hand limit. What does it look like the y's are approaching there? Looks like 2 to me. What about coming from the right? Are those also 2? Yeah, so the limit as x approaches 0 of h of x will be 2. Okay, so that's how to do limits with a table. The only additional thing you may need to do is what if you don't have the table, right? What if you have to create your own table? And that's where technology comes into play, okay? So if you want to go ahead and write down f of x for me, it's 5 times the quantity x minus 8 all over sine of x minus 8. Don't go cancel happy on me, okay? Don't do that, please. That x minus 8 in the denominator is inside an argument, so you cannot cancel it. It's not a factor. All right. Okay, so I'm first going to show you on Desmos, and I hope that it did not clear here. All right, so I've got f of x in line 1 here, so I've typed it in already. Now, right above that first line, you see like a plus sign, an arrow, and then a little gear. I want you to hit that gear, and you get some options. The first option is what looks like a chart or a table. I want you to go ahead and click that if you're following along on Desmos. And now you've got a table, right? The only thing is most likely your inputs are not going to match what you were asked to find. Okay, so let's just type in the inputs we wanted. So in the example, we wanted 7.5 and then 7.9. And then 7.99, what does it look like? What limit are we trying to find here, by the way? Probably the limit as x approaches 8, right? All right, and then we wanted 8.01, 8.1, 8.1, and 8.5. All right, so can you tell what the limit is as x approaches 8 here? So I come from the left using x values less than 8. Looks like my y's are approaching 5. And the same thing coming from the right. If I use x values greater than 8, my y values are approaching 5 as well. And if you can see, actually on the graph there, we do have the 0.85. Okay, now if you want to use an 84 instead, I'm going to get a little bit low tech on you here. I apologize. It's the best I could come up with. So you are going to first go to your y equals and put your function in, and I've done that already. Okay, then you're going to want to set your table. So you're going to go second window. See where it says table set there? Okay, and now what I want you to make sure that the independent variable is set to ask. Otherwise, it's going to just automatically populate that table very similar to what Desmos just did for us. So you want to set it to ask so that you can input your own independent values or your own x values, okay? Once your setup looks like this, you can go ahead and go to your table, which is second graph, okay? So second graph, and now I can just put the values I wanted. So you can go 7.5, enter 7.9, enter, and so on and so forth. And you can see those are the same y values we were getting on Desmos, okay? And if, by the way, if you need more decimals than than is being shown in the table, just hover over that number and see how I get all those decimals down here. Alrighty. Okay, so that is how to create your own table in both Desmos and an 84. So that is all I have for you. You've got some homework you can either try today or tomorrow on my math lab called Limits Numerically. And then the other thing we ask that you do by the end of this week is just to check in with your math teacher through a Google form that you should be getting from him or her. And as always, please email us any questions you have, reach out to us in whatever way you're used to reaching out to us, Canvas, Remind, email, etc. We miss you all very much. We wish we were together still, but we're super grateful for technology that can keep us connected and keep us learning. So we miss you all. We will talk to you soon. Bye.